What did we do without that introduction?
So basically, basically on Wednesdays we'll go around and then we'll sponsored by Terry, and then we'll talk about stuff, how to make money, yeah.
How to make money? So far I've not been successful.
I never make much
So
money.
disclaimer, start first.
This is not financial advice.
Yeah. If the previous is a prediction of the future, this is a sure lose money. But we never give up.
I can see you are.
Okay.
Fortune favors the brave.
Fortune favors the brave.
Oh,
We are doing the same thing we do every night, trying to take over the world. Always fuck up. Okay, please.
okay, so basically we had a talk on Bitcoin the last time round. We like summarized it like a little bit, right? And I'm going to go through the same each one. I skim across a lot of details on how Bitcoin is going to work, but we're going to just try to do it as how do I say, as simplified as possible. So try not to ask too many questions that dig into too much detail.
Always go up.
Yeah. Okay, so in order to talk about like how Bitcoin works, okay, so who would say that they kind of like know how Bitcoin works? Okay, and those who have attended my last talk on Bitcoin, I remember some big faces. Okay, so basically, okay, but everybody know what Bitcoin is, right? It's a digital asset, right, on chain. If you don't know, then never mind. Just feel lost the whole time. Okay, so today I want to talk about Bitcoin and the Lightning Network, right? And I'm really going to go really quickly into Bitcoin first. And so in order to learn about Bitcoin, you first need to learn about a little bit about cryptography, right? And so number one thing I want to talk about is what is a hash, right? This is a very, very important concept in Bitcoin. Basically, a hash is just a computer function that takes a bunch of data, which is like, let's say, a string data, and then converts it into a 32-byte stuff, right? So like this. Whatever lah. Okay. Basically, it does this. Very simple, right? And you cannot. So this is what we call a pre-image, right? A pre-image. So a pre-image is basically the origin thing, and then you hash this. So if you give somebody this, you only can see this one. You will never be able to guess this one. But if you give this one, this usually is like SHA-256. Okay, I'm going a bit too slowly, but basically, you SHA this, you get this. Always, if you take this and then you always do this, you always get this one. But if this one change, like let's say this E become 3, then this thing will not look the same, right? E, C or whatever. Okay, like that. So this pre-image, when you hash it, you will get this one. And this is a very important concept. Anything you change here, you will change this one. Right? And so that kind of means that this thing is also called a digest or like a summary of this one. There is a provable summary of this. So one interesting use case is that like somebody can post, let's say today I want to make a prediction, so I predict that tomorrow going to rain. Right, going to rain. What I can do, interestingly, is I can hash this thing, right? And then I put this hash, let's say, I put this hash 0x256, like something like that. Let's say on Twitter, right? I put this on Twitter, and then tomorrow when it rains, I will publish that, hey guys, look, I kind of knew it was going to rain, so I published this one. So on the second day when it rains, you yourself can take this sentence, hash it, and achieve this to prove that I actually said that it was going to rain before it rains. Okay, this is one way, interesting way of hash being used. Right, so this is basically the hash. Okay, so basically, I'm gonna.
That's what you do, right?
Yeah, so the hash is the hash first. Like so if you change anything here, it will change here. So you can say that this thing is immutable, right? And so you can review this thing, right? So basically, what the blockchain is that is a group of transactions right, that is hashed to a certain value, right? So you would say that this hash, which is the header, right, is a hash of all the transactions within it. Okay, like that, right? And so what happens? So basically, if you have a list of transactions here, and you hash all of these, I mean, this thing can go long as possible. Like, it doesn't matter how long it is. It can be like as small as one alphabet. It can be as big as, you know, one entire passage or gigabytes can hash. It will just hash into a 32 byte, like a standard size thing. So when we hash this thing, we'll get, no matter how many transactions like you can arbitrarily long, you can hash into this hash. Let's say 0x7c7. Okay, let's just put it there. Right? And so basically what happens is that in the blockchain, we actually have a chain of transactions, right? We basically have transactions. We call them a block. Right? What happens is that this block's hash actually contains not just the hash of all the transactions, but also this previous hash, which is this 7c, is included into the hash of this one. So when you take this thing and and you hash these two together, right? You get the new hash for this set, like something like this, right? And then because you did that, this hash is a summary of this thing, right? And this thing is summarized also by hashing it like that. So this plus this and hash means this summary is actually included in this one. And then if anything here change, right, then this thing will change. But if this thing change, this thing hash will also give you a different number, right? So that means that nothing here can be changed because, and all the way to the very beginning, because this thing will be, this hash will be hashed together with this one to form the new header here. Okay, like that, right? So basically, then there's this thing called, so Bitcoin has a lot of nodes, right? So the whole bunch of nodes. But let's say if you imagine Bitcoin only has one node, what the node will do is to validate all of this. So it will take this list here, it will hash it with the previous hash and get this one and say, okay, good, right? And then you take this hash and this one and you hash it and get this one and say good, right? And take this one and you hash it and say this one is good. Okay, so therefore it can, as today, let's say if you sync a full node, you validate the entire chain and make sure that all the transactions have not been tampered with and are accurate down to the genesis block. Okay, so that's on the gist how it works, right? And there's multiple nodes. So every time, so there's just a lot of nodes, and these are Bitcoin nodes, and then they just talk with each other, and basically they share all the transactions in this thing called mempool, right? So there's a mempool with a lot of transactions free floating around. So each one of them keeps a copy of this thing. So there's like multiple copies of this, right? And then they pass new transactions to each other, right? And new transactions to each other, one person will say, okay, I created a transaction, and then they mine the number, they mine it. I'm not going to talk about how it mine, right? So the proof of work mining, you'll just mine it. They'll prove that they are the ones that are eligible to make the block. So they'll make the block, they'll hash again this number and this transaction, and then form this new 0x777. Okay, like that. Okay, so that's pretty much in a glance how the blockchain works. Okay, so basically this, okay, let me see what's next on the list. So I have hash again, another hash, okay. Okay. Okay, so I'm not going to talk about the nonce and difficulty. So you're kind of like get how it works and how it forms and how it is actually validated and how this thing continues to be a distributed ledger in the system. Okay. So I want to go inside and talk about these transactions and what is inside one of the transactions. Oh wait, this is a bit, okay, let's digest this for a bit. Because yeah.
Oh, when are we going to get the line?
We are going to
waiting for the lightning part.
Yeah, lightning part. Okay.
L2.
Okay, so good. Y'all digested this very fast. Okay, very good. So basically what's inside the transaction, here comes the part that I didn't teach before. So this one I already teach before already. So inside the transaction, right? So inside every transaction, there is two parts. There's the inputs
Oh, that's curious.
and the outputs, right? So in every single one of these transactions, when a computer, right, broadcasts, okay, or full node says that, hey, I have a new transaction I want to add to the system. Basically, when a full node, okay, a computer, let's say today computer, I broadcast a Bitcoin transaction, right? And this Bitcoin transaction, which is like that, is going to go into other nodes and spread like BitTorrent like that, right? So everybody will have a piece of this inside their mempool. Like this is the mempool. Okay, so inside the mempool, then the worker that did the hardest work will have the chance of putting it into the blockchain itself as a chain like this, right? But you have to pay enough fees for them to want to put yours inside because there's a lot of transactions here. So they will pick the highest, they'll just sort this list by who pays the highest fees, and then they'll form this block and then they'll put it at the end. Once it goes in here, means you are on the blockchain. So that means the money is actually, the transaction actually is final already. Okay, not necessarily final, but basically final lah. Okay, basically final, right? Yeah. In order to avoid confusion, you count it as you spend your money already. Okay. So what is inside this transaction when it's broadcast here, right? This transaction inside actually, how much money you have actually depends on how many of this concept called the UTXO, which is the unspent transaction output.
By the way, this is not how Ethereum works. Bitcoin is unique.
Output. Okay. So unspent transaction output. So you can spend a transaction. So you can spend the output of a previous transaction. So for every transaction, the input is basically a previous transaction ID, right? The index, and what they call a script sig. Yeah. Okay. These three parts. Okay. So the previous transaction ID is basically one of these transactions. Let's just assume that order ID. Let's just assume that this transaction is a special transaction that somebody sent money to me, right? This is my transaction. So this transaction, this previous transaction ID will basically point back to this one.
I think the left is the script hub key. Right there, script again.
No, I'm correct. Yeah. So yeah, because you need to sign this thing called the sigma, right? Don't worry. Okay, so basically points back to the previous. Ignore the index for now, right? So this one is this one, right? So when I point it back, inside the output over here and over here also is who is allowed to spend this output, right? Who is allowed to spend this output? So inside this output, there is a script hub key, as well as amount, right? Of course, right? Amount. Right. So let's say today somebody sent me 10 Bitcoin. Wow, sure. 10 Bitcoin, right? Somebody sent me 10 Bitcoin here, right? And this 10 Bitcoin is my unspent transaction output. That means this pub key is say that like whoever that can spend this can spend it, and whoever can spend this must have the right secret, right? Over here. So I create this new transaction to send, let's say, 10 with 5 Bitcoin, right? Because like, yeah, 10 Bitcoin I just send for fun, right? So what happens is that my transaction here, I signify that this input is actually spendable by me by signing this entire transaction, including this script sig with my private key. Okay, wait, before I talk about that, I need to tell you what about yeah. So then now we need to go into asymmetric encryption. Yes. This is why we need this whiteboard so big, right? Okay, so basically, let me see. There is two keys, right? And then
What does it happen? We just want a second.
yeah, this is going to get complicated real soon, but. Yeah. No, because if you don't understand all of this, it's very hard for you to understand what lightning is.
So this is the primary school apparently.
Yeah. Okay. So, I mean, it's also good for you to kind of understand how Bitcoin works, right? I mean, so you can treat it as Bitcoin works until you learn the other part. So basically, it's very simple. This public key, right? You can think of it. Okay, so let's say there's A and B. I like to use the Isaac and Bobby. This one is the Alice and Bob. Become Isaac and Bobby. So Isaac has a private key and public key, right? So let's assume that you all know how to generate a private key and public key. Generally, basically asymmetric cryptography is about private key, public key. And so you can think of public key as kind of like a box. Like it's in the public domain, right? So this is the public, right? This is private. Right? This is private.
The private key is not a
So
crypto address is different also.
So this let's say this is just a key lah,
Not the
right?
same. Public key and address.
Private key. Okay. So there's a public key.
With
Right.
the key you can access the same.
So you can think of the public key as Bobby's box. There's a box.
Address is derived from
Let's okay, I can't draw a box.
Reverse.
But basically let's just draw a box like this. Okay. So let's assume that there's this box, right? That only this key can open. Right? And Isaac also have a box that only his key can open. Right? So he opened the box first. I open the box, then Bobby will take the box, right? And put the key inside, put the message inside, right? And then close the box since it's locked, right? And then put it out in the public, right? So only Isaac that has the key to open this box can take the box, open the box, and take the message out. Make sense?
Yeah.
Okay? And so if you think about it in that way, this is pretty much how it is. And so for public key, you can encrypt, which is put inside the box, right? Encrypt a message, or the simply put inside the box, right? And then you can decrypt. Okay, sorry.
What do you do with the private key?
So this will become the closed box, and then you can decrypt it with the public key, right? Which is open the box, basically, with the private key. And then you get the message. Okay, simple, right? But if you have the message, you can use the private key to sign the message, right? And then, if you have the public key, you can verify the message. You can verify the signature. Okay, this bottom part is a little bit away from the box analogy, but basically what that means is that this way you understand. You put things into the box, and then the other guy can unlock the box and take out the message. But if let's say today you are the key owner and you have the message, you can sign the message and form some sort of a cryptographic number, right? And then this guy with your public key can verify that you were the one that actually created this signature. Okay, cool. If you don't understand, there is no time. Okay, so let's minute for you all to digest it a bit. Okay, so I will go back to this later as I continue explaining this. So basically, if you think about it from first principle, it's very simple, right? This input, somebody want to spend that input, and then this output, somebody needs to provide the proof that they can spend the output in a verifiable way so that they can spend the output. They can spend the output. And in spending the output, they must declare where the output should go in terms of like who can spend this other output. Right? So what is in this script part key is that this is the predicate. Okay, the predicate is a bit harder word. So it defines the rules of who can spend this output. We just talk about outputs now, right? So that means today, if you are, let's say, Tian Wei, I send him 5 Bitcoin, but he need to, I send him 10 Bitcoin, I say, whoever I send it to Tian Wei's public key. So I take his public key from the open web, right? And I send it to him. His Bitcoin address is his public key, right? So he has the secret key to his Bitcoin address, which is his secret key or his like 24-word thing, right? So that 24-word thing, he must sign a new transaction with, and he must create a new transaction, right? That says, okay, I point this one to Heng Hong's 75 Bitcoin, right? And then I say, okay, I want to send 2 Bitcoin to Mark, right? I want to send 3 Bitcoin to Shumper. He can have a lot of these, right? But then he will sign this entire message with his private key to form the script.
Ten is sending to
Yeah,
sending
Tail
the
is
file
sending to you
to
and
the
yeah,
other file, right?
Tail is to send to other people,
Okay.
right? So I send to Tail, I of course have created this already, and then I put his public key here, because I take his public key from, I take Tail his public key, so this is a script up key lah, right? And I put his public key here, so whoever has the secret key to this public key can spend this 5 Bitcoin, right? Which is whoever, may not be Tail Wei lose his key, it's not him anymore.
In this case, Tail
Not your key, not your Bitcoin. Yeah, that's where the story goes, right? So in this case, yes, it's Tail Wei. So Tail Wei, on his side, he must create a new transaction, the completely new one, and define the outputs and inputs. That means if he don't spend it, it will still be there. It's not actually going into his pocket, it's still on chain, it's here, right? If he want to spend, then he can use. So to Tian Wei, actually, the 5 Bitcoin initially was an unspent transaction output. So he haven't spent yet. Okay, so when he want to spend, and so Tian Wei could have many unspent transaction output all throughout the blockchain, like here, all the way down, right? He could have a lot of Bitcoins. So when he want to spend, he will create this one, he will point to the previous transaction ID, and then he will sign the entire message to confirm that this entire message, and nobody gonna change the amount here, right, is spendable by him, and send it here to this. Can also, can multiple this one, multiple this one, multiple this one. So if you think about it, so there's an analogy to cash versus your bank account, right? So the Bitcoin system looks actually like cash. Your unspent transaction output is actually like your $2 note in your pocket. You used to buy twisties, you pay the guy $2. He will give you, $1.50 in as a change, right? So the amount here, you can have a few, right? And one of them could be you pay back yourself, right? So you put yourself, like if this is like twisty, it costs 1 Bitcoin, then you put 1 here, you got 5, right? Then you put 4 here for himself. So he'll put his own address here again. So he will then have a 4 unspent transaction output. So this is like change lah, right? This is I pay this person. Okay? So the
input always equals, inputs always less than equals to outputs always less than equals to inputs.
Yeah.
Okay, so this model works like that. Okay, let me see what's next. Wait, you all digest the buffer.
Still waiting for lightning.
Okay. You all digest.
Wow. Are we gonna walk?
This is the setup.
Yeah. So
Prep you for the next step.
yeah.
Yeah, my goal.
So now you all are expert on Bitcoin already. Yeah. So now you all are expert on this already. So what happens in the Lightning system? Before we talk about Lightning network, we want to talk about what we call the simpler version of the Lightning network, which is called a one-way payment channel. So this entire system here works on the chain, So that means on chain, what that means is that every time you do this, let's call it like, let's put a name here. Let's say let's call it broadcast. Like let's just put a real verb to it. You broadcast a transaction. So your transaction ends up here waiting forever, or gets into the chain itself. Okay, when you broadcast the transaction, the transaction will stay here until somebody picks it up. Some miner picks it up and puts it in the chain, and then that's kind of like confirmed. Not confirmed in the real sense, but confirmed.
Miner and validator are they the same for Bitcoin?
Yes.
Confirm the same.
Well, you are full node, you can validate,
Then you don't
but
mine, right?
there's no such thing as a validator. You know what I mean? Yeah, you are a miner, or you have a full node. Yeah.
Different thing, right?
The full node can mine also lah. Everything is all in one lah. Yeah, but if you want to create a full node, you have to validate. Yeah, but okay.
Doesn't a miner need a full node?
Yeah, the miner needs a full node. Yeah. Okay. So the broadcast important. Okay. So this thing happens on chain, and this creation of the UTXO or creation of the transaction itself, right? That happens on your own computer. Right? The creation of this transaction, before you broadcast it, the transaction happens on your own computer. You sign on your own computer, you determine the input amount, your script key, everything on your computer. Then you send the transaction, broadcast it to the network, to the Bitcoin full node network, and pray that it will get inside here. once you get inside here, it's confirmed. So if you say send, but then you never get confirmed, you actually never send. Okay, so the Lightning system works like here, right? So from computer to computer, right?
Oh, but
The
so it works on
transactions,
pre-broadcasting.
yeah, happen
Oh, okay.
outside. Okay, so what we call there in the payment channel. So, so the payment channel basically how it works is that first is funded by a 2 of 2 multi-sig. This thing is getting more and more complicated. So, okay, so what a 2 of 2 multi-sig means is that this script pub key, when I create this transaction, I can say that like I send 5 Bitcoin to Tianwei, but Tianwei can only use the 2 Bitcoin, right? If me and him sign together, okay, so that comes back here again, right? So this thing can be done like commutatively. Basically, you sign, I sign, so the box can be inside the box like a Russian door, you know?
Multi-sig.
Yeah, so the Russian door in the box, so the box open already, then must open again, right? Then you can find the message. So you can do a double like Russian door-ish like signing to this signature. So here we want to spend that 5 Bitcoin, you need my signature also, right? So if I sign the transaction and let's say so here we will create this transaction. He say, oh, I want to give Mark 2 Bitcoin, I want to give Xiong 3 Bitcoin. He sent to me, he said, I signed already. Hang on, you sign, then it's done deal, right? So he will send to me, I sign it, then he or me will broadcast, and then when it hits the network, then you all get your Bitcoin, right? So, and it gets confirmed, you all get the Bitcoin. So the same thing happens here. So this basically the output, right? So there's 2 players here. There's Alice and Bob, right? Isaac and Bobby, right? When Alice can create, somebody has to start the channel. So when we start the channel, it's Alice and Bob 2 of 2 multi-sig output. So let's say we put 10 Bitcoin inside. So the amount is 10 Bitcoin, right? And then there's a 2 of 2 multi-sig script sig here. Script pub key, right? 2 of 2 multi-sig here that need both Alice and Bob's signature on the next transaction to spend this one. Okay? And so if both of them sign, right? The next transaction, not this one. Okay, so this transaction I draw here. Right? This is the output, right? Output. Right, so this is 10 Bitcoin. It has 2 of 2 multi-sig. Okay. So this transaction, right? Okay, so only to spend this, we need a transaction, right? That has that points to this one first as an input, right? And then this output, it determine who get how much lah. It can be 2, right? 2 output. 1 is like send to L. Okay, this A is misleading. Okay, send to A 10, right? Okay, as in like the pub key of A, right? So the pub key of A 10, the pub key of B 10. So 10, 0, right? Okay, let's say 9-1. Sorry. Now you're listening very good. Okay, so let's say 9-1, right? So let's say I create this transaction and I get both signatures, I can spend this one, and it can go there. It can go to the 2 people, right? But what happens if I create this transaction and I don't broadcast it, right? So if let's say today I'm Alice. Okay, let's just make this easy, right? Let's change this to Heng Hong and then just change that to Tianwei, right? Okay.
So they
easy for me.
Keep their own like repository of unbroadcasted networks.
Yes. So I have 10. Me and Tianwei, we sign this 10 Bitcoin. Actually, all the 10 is mine, right? I put it there first. Okay. And Tianwei cannot retrieve it because need 2 of 2, right? So Tianwei will need my signature to take any of the Bitcoin out. So I will say, let's say I send Tianwei this transaction, and I sign it, right? I said, okay, so Tianwei buy me the food, right? He buy me the burrito, cost 1 Bitcoin, fucking expensive. Cost 1 Bitcoin, right?
So fast.
So I say, okay, I pay you. I create this transaction, I sign it, I send it to Tianwei. If you want, you close. Right? You can close this transaction right now. and then after the blockchain settles it, you will get your 1 Bitcoin. Okay, but you can don't close, because tomorrow or next Wednesday you buy me again, I can send you another one, right? And same transaction, but now, you know, this is Tian Wei. This is me, right? So HH become 8, Tian Wei become 2, right? So the same pointing to the same one. HH sign this one. When I send to Tian Wei this one next Wednesday, Tian Wei was stupid go and publish this one, because this one he only get 1, this one get 2. So he confirm will publish this one. So this one is pretty much useless, right? Right? Makes sense, right? So as time goes by, as long as this thing is off chain. Remember, this thing is off chain. So off chain, what that means is that this thing is instant. When I send to Tian Wei 1, he pretty much cryptographically has 1. If the Bitcoin network don't collapse lah, basically, he has the luxury of time to publish this one and take my Bitcoin.
It's a check lah, basically. He's a cashier's
He's
check.
a check.
Yeah.
Well, it's more better than the check lah. This thing is locked up, right? So like, I give him a check, we might not have money inside my bank. Right? Cashier's check, they escrow your money, is it? Yeah. Cashier's check, right? So, but then cashier's check cannot give another one, right? So this one, so it's a payment channel, right? So I sign another one and I give him. So this is how a one-way payment channel works, right? So basically, of course, there's a lot of things. Okay, but digest first this one. Yeah. So this is me forming. So I created a channel with Tian Wei. I funded with 10 Bitcoins, and Tian Wei bought me some services. I pay him with 1 Bitcoin. I sign the transaction. I make it 9-1. I make it 9-1. I'm not Tian Wei. I make it 9-1. I sign, then I give him. Right? Then he can choose to close it, or I can say that, oh yeah, don't close first lah. You know, we keep it open. We keep our tab open, right? So anytime you want, you can close, right? Because he feels like, okay, I can close anytime. You know, things not gonna run away. Hang on, not gonna run away the money. So then we continue paying this one, right? Okay.
So what happens when we close one? Then does that expire the first one?
Everything goes away.
Everything goes away.
Yeah, everything goes away into, it just basically collapses all this information into a transaction over here.
And so then you have to open the tab again. To open the read tab, it's opening that one same output with the 10 Bitcoins.
Yes, correct. So if you want, you can do another payment channel. Okay.
Because they're output gone already, once you do, so if you do the 911, you cannot do the 82 anymore, because once you use the 911, the output that has 10 is gone. You need to send the new UTXO.
Yeah, well, you guys learning very well.
So that means
all these things.
That means on chain
Yes.
they only get the final state.
Yes, correct, exactly. So on chain, you actually don't see much. You only see that here we got 92, yeah, 92, 82.
Right? So
You only
the
see 82.
91 doesn't exist.
91 does not exist, yeah. 91 does not exist.
But some cuckoo can just accidentally put the 91.
Yes, cuckoo is for
Yeah, cuckoo is good. Good for me. Here we best cuckoo if you can do this. Right? So the system, the protocol doesn't need to solve that because
cuckoo doesn't protect.
Yeah.
The system doesn't protect cuckoo.
Okay, quick one. Maybe like there's a lot of failure cases which I kind of try to avoid here. So number one is that what happens if these 2 of 2 multi-sig, I form this payment channel with Tian Wei and Tian Wei run away, or he passed away, or like anything, right? What happens if it stopped responding to me? Then my 10 Bitcoin is locked in the system. So actually, okay, yeah, this one goes into another thing around this thing called script key. So this script key is actually a script. While the most simplest version of the script verifies your public key signature, right? While the most simplest one verifies the one box or this verify. That's the most simple part of the script. The script actually can do a little bit more stuff, right? So what happens in the script is that there's this thing called check sequence verify, or like there's a time version of this script, time lock script, kind of unlock it, so to speak, right? So you can say that Tian Wei can spend the money after 100 blocks, or 100 blocks means 10 minutes per block, 100 blocks means 100 minutes.
So channel will
1,000 minutes. So the channel you can, so to speak, sign a prenup on this one, right? So that both people sign this Literally, that's what they use in the lecture. Both people sign this prenup transaction that takes this 10 and returns it to Alice or came with me, or returns to me, right? Signs this and returns it to me. Alright? So
intermediary, if you already did something, the return still can work.
So I will not be able to spend this even if I publish it. It will not be able to spend this transaction. So it will still be considered an invalid transaction if I cannot spend this output because of the time lock. So that means you create this transaction, we publish it, right? Only after the time, let's say 100 blocks. So today I formed
But
this
the 100
channel.
block publishing is the pre-signed signature transaction of returning the 10 original Bitcoin
Yes.
back to the original Bitcoin. But in between, there might already
If let's say you come back and start doing this, right?
Yeah.
Correct. So this, okay, so there's another part of this one. So this is the one part
that protect the original.
that protect the original owner first. So we have to close this channel, let's say before 100 blocks.
Yeah.
So that the original me cannot use these things to take back the money.
Correct.
Right. So maybe this might be quite long lah. Maybe not 100 blocks lah. Maybe
Yeah.
like 50 days or something like that.
Yeah.
Right. Like quite long.
But the moment I close one transaction, this
Yes, you
prenup
close
is
this
useless.
transaction, this one useless already.
Yeah.
Yes,
So you have to
exactly.
keep signing prenup, is it?
No need, because I keep signing this one and send to you, right? Because if I create the transaction and I don't start doing this with you and you are unresponsive, 50 days later I'll get back my 10 Bitcoin lah at least.
Oh.
Right? Yeah.
Because it's with you who created it. Oh.
Because before I create this one, I asked you to sign the prenup, right? You need to sign it with the prenup. Yeah.
You have to talk about like malicious intent.
There is no malicious intent here.
You
How?
can, right? So if I send you 1 Bitcoin.
Yeah. Wait, by what? This way?
Yeah.
Okay, Heng Hong and Tian Wei. Heng Hong sends Tian Wei 1 Bitcoin. Tian Wei is of course the malicious guy.
And
there,
then
yeah.
you
Yeah.
publish the prenup saying, okay, now
Okay.
I want my 10 Bitcoin back.
Yes, so you are unable to spend this. Okay.
Pre-set up timing.
Yeah, because there's a pre-set up
Okay,
timing.
you must do it before your prenup.
So this 50 days, yeah. So only after 50 days, this transaction is able to spend this output
Okay.
because it is inside here, right? Is 2 of 2 multi-sig or time pass something.
But it still doesn't solve the problem that, let's say after 2 transactions, I become non-responsive.
Huh?
Right?
You mean you become responsive after the first transaction?
No, you become non-responsible after the
Oh, that's fine because this is a one-way payment channel. So I don't care, right? So one-way payment channel, one way. So this is not all, by the way, guys. This is just the beginning, right? So I want to go to the two-way payment channel first because that's going to be even more complicated than this one.
No, but okay, now we have 8-2, right?
Yes.
There's still 8 blocks in the system.
So you are saying I disappear.
No, I will.
You disappear, then good lah. I wait 50 days, I get back 10 ma.
But I will publish, let's say I publish the
By the
8-2.
10, 50 days over.
After I publish the 8-2, I publish the 8-2,
Oh, you publish there, but broadcast to the chain lah.
Yeah.
Then my money is gone lah. You took already ma.
or then the 8 will be actually...
8 will go back me.
Oh, okay.
Right, yes. Okay.
Can.
Okay, one-way payment channel. This is the beginning of Lightning Network.
Okay, next lecture.
Yeah.
Thank
So
you.
yeah, I think it's kind of good to stop here actually. I don't know if I actually plan to talk about two-way payment channels, but
Today class session, need to buy token to carry on the next session.
yes, I did not. Yeah. So this is the very much the beginning. So yeah, this is the beginning of Lightning Network, and so if you do Lightning Network, this is basically how your transactions actually go through.
How often does the Lightning Network publish to the main chain?
So
is there a fixed timing that
well, it depends on who's the operator of the Lightning node, right? So this is your Lightning node.
Blue
right?
Wallet strike different lah.
Yeah. Oh well, that's centralized. That's another thing altogether. So the thing is that, okay, I give you all more teasers, right? Like, this thing can go both ways, right? Back and forth. There's a two-way payment channels also, and in two-way payment channels, you can also once you're done with two-way payment channels, you can form payment networks.
Can you have multi-way?
Yeah, exactly. So 2 ways is just 2 ways versus 1 person, right? But basically, in Lightning Network, they also do onion routing. Like onion routing is the Tor network routing. So basically, Alice and Bob, right? And let's say
Route through someone.
Charles, right? Yeah. So you say if Alice sign a transaction and say, hey, But if, okay, so Charles, let's say Charles has a private key and public key, right? So they take the public key and send to send to A off chain, or just send there lah, because it's totally off chain. Says if you can get the private key, I will from Charles from the recipient, I will give you 1 Bitcoin. Then this one will send to here. So basically, Alice will send to Charles through bot, and that extends infinitely to form the payment channel.
Is really untraceable, not even unchained, traceable money laundering.
Yeah, potentially I think it's completely untraceable. Yeah. Potentially, I don't know. Actually, I haven't thought through that much. But yes, essentially. Sorry?
Multi-party live already.
Yeah, everything is live already. Yeah. So yeah, it's not a chain, it's off chain.
This thing or like
Everything here is off chain. Everything here is on chain.
So Lightning Network is an off-chain,
I think it's Blue Wallet, Strike Wallet, the other thing.
I think it's off-chain.
Off-chain.
I thought it's on-chain but the other chain.
Money lending layer 2.
On-chain,
So it's actually centralized.
Yeah, because on chain is slow, but if I send you, it's fast. Right?
Scaling solution, huh?
Right? It scales layer 2 off chain. Yes, off chain.
So I guess the idea is that they will do all this nonsense, right? Package it together, then they choose, okay, certain time we finalize to publish the truth lah.
I thought level 2 means that they're actually doing on-chain but using a different protocol. For example, you use like Matic to calculate. You use a different
chain.
different chain to calculate.
There are different solution to different layer.
I meant it's a side chain.
But Lightning itself is on-chain.
1.5, yeah.
Oh, okay. Oh, I didn't know that. I always thought it was on-chain.
Well, the concept of chain depends on how you want to describe.
Yeah.
Okay.
Right?
I can make this
They,
thing on
they say
the
that this is
chain.
chain, ma.
Yeah.
This is chain within my system, ma.
They are
There's only
own
2 nodes,
system,
me and myself.
But end of the day, they still use the main chain to
Yeah.
do the source of truth, huh? But the transaction is also off chain. Like you say, Matic is like all the shit is on the side chain.
Also between the node hosts, they can also do
push back consensus to
so
maintain.
like,
Yeah.
between
Same
the Blue Wallet
optimism
and another wallet provider,
Arbitral, right?
also do
One is
consensus lah.
they're doing different things. One is like
Yeah.
ZK rollup and one is
So it's actually
so it's quite interesting. They all do different ways.
It is, yeah, it is. But
They all are all L2,
Underlying chain
but
first.
the way they do